Okay, ladies and gentlemen, let us look on page 74. This is entitled, before we get to problem 16, we need to do a little talk up here. This is called complementary events. Okay. The probability of rain plus the probability of not rain is equal to what? Well, let's think about it. Let's pretend I told you the probability of rain would be 0.4, okay? The probability of rain would be 0.4. Well, remember, if an event's going to occur for sure, it's a 1. If it's not going to occur, it's a 0. So here's what's kind of cool. If the probability of rain is 0.4, that would mean the probability of not rain would be 0.6. All right? They always have to add up to 1. If the probability of rain was 0.2, the probability of not rain would be 0.8. So the probability of an event plus the probability of the event not occurring is always going to add up to 1. So if I said the probability of an event occurring plus the probability of the event not occurring is equal to 1, if I do a little bit of algebra here and I move this over to the other side, the probability of the event not occurring is equal to 1 minus the probability of the event occurring. So here's a little formula. These 3 dots mean therefore, the probability of an event not occurring is equal to 1 minus the probability of the event occurring. So that's a good thing to keep in mind. So I'm drawing a single card from a deck. What is the probability of not pulling the Queen of Hearts? Well, the probability of not pulling the Queen of Hearts, let's follow our formula, is 1 minus the probability of pulling it. So we would have 1 minus the probability of pulling the Queen of Hearts. Think about that. There's 1 Queen of Hearts out of 52 cards. And let's do a little bit of work here. Not much. We have what? 1 is really 52 out of 52 minus 1 out of 52 would be 51 out of 52. That would be the probability of not pulling the Queen of Hearts. Okay. Part B. What's the probability of not pulling a picture card? Well, that would be 1 minus the probability of pulling a picture card. So that would be 1 minus, okay, we know we've got 52 cards in the deck. How many picture cards do we have? Well, we have an ace, a king, and a queen, correct? For each suit, and there's 4 suits, so we have 12 picture cards. 52 over 52 minus 12 over 52 would become 40 over 52. And let's see, if I start reducing that, if I divide by top and bottom by 4, it looks like I get 10 out of 13. There we go. There's my probability. The probability of not getting an ace, let's use complementary events, would be 1 minus the probability of getting an ace. So 1 minus, out of 52 cards, the probability, there are 4 aces. So we have 52 out of 52, that's what the 1 became, minus 4 out of 52, we get 48 out of 52. Let's try dividing by 4. So the top would be what, 12? And the bottom would be 13. There we go. So we reduce it. Now this time it's rolling a single die. Okay, we're not doing cards now. Okay, the probability of not getting a 5 would be 1 minus the probability of getting a 5. That would be 1 minus probability of getting a 5 when you're rolling a die. There's one way to get a 5 out of 6 in the sample space. This time 1 is going to become 6 over 6, right? We need a common denominator. Minus 1 over 6, and that gives me 5 over 6. All right? What's the probability of not getting an even? Well, that would be 1 minus the probability of getting an even. That's 1 minus, okay, we have 6 outcomes from a die. 1, 2, 3, 4, 5, or 6. And the even would be 3. 1 minus 1/2 is 2 over 2 minus 1/2, which is 1/2. So basically what you've learned on this video is what it means to use complementary events. And the basic formula is right here. The probability of an event not occurring is 1 minus the probability of the event occurring. And we've used it several times here. It's a good little formula to know.